So a little bit more about substrates while we're there. Substrate material in contact with a waterproofing system shall be suitable for and compatible with the waterproofing membrane system. Right, so substrate has to be suitable for external use and compatible with the membrane. Therefore, it says particle board sheeting shall not be used as a substrate for external waterproofing systems. Right, so particle board can't be used externally. Hang on to that bit. That's actually going to get quite important a bit later on when we talk about a bit more details. And of course, the substrate shall be resistant to moisture damage caused by condensation forming on the underside. And that's why if you've seen a Scyon board that's got the fiberglass epoxy layer on the bottom, that's because of that. Right? It makes it resistant to condensation forming on the underside. And if you didn't think anyone would be crazy enough to put chipboard outside, yes, it does happen. So let's talk a bit more about specific substrates. So generally for external waterproofing, you're going to find concrete, you're going to find compressed fibre cement, Scyon, Durafloor, NX boards, and Cementel also have a product. So with all of these, there have to be falls to the drainage outlets. So the standard says falls in finishes shall ensure that water drains to the drainage outlet. Water shall not be retained on a finished surface with the exception of residual water remaining due to surface tension, and falls for surface drainage should be no flatter than 1 in 100. So the standard's always talking about what happens to the finished surface in these sections. All right? But it also has an additional clause which says the fall shall be in the structural substrate or formed by a screed over the structural substrate. So what the standard means is if you don't have fall in your substrate for external waterproofing, you must form it with a screed before the membrane goes on. All right, so if you need to create fall, screed first, then membrane. And that wasn't done in that picture I showed you earlier with the efflorescence. All right, they had no fall. It was actually an area where the structural substrate had a dip and it held water. They waterproofed it and then screed it over the top of that. So that area there where the dip was holds all that water. And there's only one way for that water to get out of the system. And that's back through the grout to the tiles in the grout, and that's what causes the efflorescence. All makes sense? So screed first, then membrane. I pressed a button and there it is. All right, so here's another example of a deck. So as you can see, membrane's gone on nice and thick, but a little bit of rain and you get a nice puddle in the middle of the deck. So I almost guarantee they're going to get efflorescence on that deck. All good so far? Another example. So this is about a 900 square metre rooftop in Brisbane. It's got about 14 of these grates in the roof. Guess what the highest spots were over the entire roof? All right. So he's standing in about 20 mil of water there. All right, so obviously it's got to be fixed. So what did they do? Primary membrane in accordance with the contract. So they put a membrane down. Then they put an unbonded screed on top of that, and that screed was in areas 120 millimetres thick. Then they put a secondary membrane on top of that, and then put ceramic tiles on top of that. And here's a picture, here's a tiler with a secondary membrane there, ready to go for the tiling. Right, so all the drainage now works. So all good, right? Here's what they should have done. When you're doing this now, the system actually gets reversed, right? So the membrane on bottom on the structural substrate now becomes a secondary membrane, right? In actual fact, you can delete it. You should delete it, all right? But let's say we're going with a secondary membrane on the structural substrate. On top of that, what they should have done is a bonded screed or put down a double layer slip sheet. Does anyone know what I mean by double layer slip sheet? It's basically black builder's film, 2 layers of it. Right? The reason why you do that, well, you either bond it or put a double layer slip sheet is, when you have a screed on top of a membrane, through thermal cycling, it's going to grow, shrink, grow, shrink, and it's very abrasive, so eventually it's just going to rub through that membrane. If you've got a double layer slip sheet there, the movement happens in between the two slip sheets. Okay? Remember that also. That's going to appear a lot in this presentation. They should have reinforced the screed, especially at that thickness. Right? And by reinforcing, I don't mean chicken wire. Right? It's got to be 1.2 to 2 mil thick galvanised wire welded together in a 50 by 50 or up to 75 mil grid. Right? Tiling standards actually says chicken wire shall not be used for screed reinforcing. It's just not strong enough. Right? So they should have reinforced it, and the metal reinforcing, the other job it does is it actually spreads the heat around better than just a screed does. They should have had movement joints in the screed, movement control joints. And those control joints then need to come up through the entire tiling system. The primary membrane then goes on top. And then the ceramic tiles are installed with a compatible tile adhesive. All right, so movement joints, control joints need to go through the tiling system. Okay, so people always ask me, oh yeah, they're going to be full of glue and full of grout. Well, they can't be, right? So you need to design the movement control joints in the screed. You actually got to plan your tile layout before you even go there, right? So it all lines up. And then the control joints have got to be free of tile adhesive and they've got to be free of grout residue. And the best time to do that is while the tiles are being laid, while the adhesive is still wet. Right? Clean the movement joints out as you go. Right? Because think about it, your primary membrane, which protects the whole system, is directly below the tiles. So the last thing you want is the apprentice going around with a Stanley knife, cutting all the glue out of the joints, right? So as you go, clean it. And the other thing is, as the glue dries, if it's already in the joints, it can actually overstress the system as the adhesive dries. A little bit more about concrete substrates. So the waterproofing standard says the preparation of the substrate for fully bonded or liquid applied membranes shall result in the surface of the substrate being smooth without protrusions, voids or formwork distortions, clean, dry and free from dust and contamination. Right, you'll find pretty much exactly that clause repeated in every manufacturer's data sheet. To aid in adhesion on a concrete or screeded surface, the smoothness of the substrate should be at least equivalent to that of a wood float or light broom finish. And I mean light broom finish. So are you guys familiar with the concrete surface profile scale? That's put out by the International Concrete Repair Institute. I finally had someone nodding. Right. It's a worldwide scale for determining concrete surface profiles. It's just finding its way into Australia. So you're actually going to see a fair bit more of this when it comes to different finishings. So basically what it is, it's a scale of how rough the concrete surface profile is. So concrete surface profile of 1 is about equivalent to an acid edge piece of concrete. Okay, I just need to stress here, yes, it's equivalent to that, but we don't really ever want you to acid edge concrete. It's too high risk. If you haven't completely neutralised the acid, you're asking for troubles. Same for pretty much every following construction. CSP2 is equivalent to a ground floor. 3, light shot blast. 4 is light scarification. 5 is a medium shot blast. 6 is medium scarification, all the way up to 9. There's actually a 10, which is even rougher than that. Okay, so that's how the concrete surface is scaled. So if you hear somewhere I need a CSP3, basically it's coming from this scale. Okay, any questions on that? So what we need for liquid membranes is basically a CSP 1 or 2, right, which is basically a ground finish at its roughest. Sheet membranes, like torch applied membranes for example, can handle a little bit more forgiving. So they can handle a concrete surface profile of between 2 and 6. Any questions on that? Wasn't too confusing, I hope. So here's an example of, well, you'd call it a CSP 8 or 9. Right? So this has been rained on. That obviously needs some preparation. But I've got to say, the waterproofer's already accepted this because he's already done his wall floor junctions. Right? So, and I know he's not done any preparation. So concrete like that, obviously not good enough for a membrane. Neither is that. Yes, that's broom finish, but it's actually too heavy. Right? So if you've ever walked across something like that and just twisted your feet a little bit, you can actually rub the top surface of the concrete off, and broom finish like that is way too soft for a membrane or even direct fixing tiles. So wood float, very, very light broom finish, single pass of a helicopter. But definitely you've seen in the surface profiles, your steel floated water wiped concrete doesn't even appear in the scaling because the Concrete Institute doesn't believe that water wiped steel floated concrete, it's really only good for a warehouse floor. That's about it. It's no good for any following surfaces. All right, so let's have a look at a Scyon deck. Can you see it right from there, mate, when I stand here? So the idea on this job is to put a membrane on and then direct fix tiles. Right? So other than the fact that someone's decided to put the tiles on there already and the fact that it's completely flat with no fall, what's wrong with that picture? The posts? Not what I'm getting at, but yeah, yes?
No control joint for that length.
You're almost there.
The sheets are staggered.
Their sheets are staggered, that's correct, right? So if you're going to put a membrane on this and direct fix tiles, you can't stagger the sheets. Right? So out of the James Hardie manual, what they say is if you have staggered sheets, you must put a mortar bed on the deck, on the product. And what they want you to do is this method relies on applying a waterproof system, a dual layer slip sheet. So here we are again with a dual layer slip sheet and a minimum 40mm reinforced mortar bed, then an additional membrane system and then tiles. Okay, so if sheets are staggered, you need to do membrane, double layer slip sheet, membrane, double layer slip sheet, reinforced screed, another membrane, then the tiles. All right. Other option, there's a workaround if you can't do that, and we often find that with refurb jobs, you can do a waterproof uncoupling membrane, all right, which is basically a sheet membrane glued on with, you know what that glue is, with a tile adhesive. All right, that's another option, and refurb comes into play because the engineering isn't there for the screed bed, or sometimes there's a staircase that goes on so you can't actually raise the top by 40 or 50mm. All right. When I talk about engineering, if you didn't know, 50mm thick screed is 100 kilos per square metre. All right, so it adds up. If you're going to waterproof and direct fix tiles, you must stack the sheets like that. And then you have a straight line control joint which is supported by the joist, all right, and then you can waterproof it and detail this joint and treat it as a movement joint. And ideally, you know, the bandages with the rubber in them and the fabric either side, straight over that, and then away you go, there's no dramas. Okay, any questions? So generally I get asked what happens if you don't. Well, that's what happens if you stagger the sheets. Just through thermal cycling, those end joints don't have a tongue and groove, so they'll close up, shrink, close up, open up, close up, open up, close up, and they will tear the membrane every time. BGC Durafloor, similar product, sheets are slightly different sizes. They also say, do not direct stick tiles to this layout. To be used with a floating mortar bed only. Okay, so same idea, and it's the same for all the other boards as well. And again, staggered sheet layout if you want to direct fix tiles. All right. But this product, and I'm not singling it out by any means, but it's a very good example of why you should read the entire installation manual and the brochures. Okay? Because if you read it, if you waterproof without a mortar bed, which is square sheet layout, the maximum deck width they allow is 3,600 millimetres. Basically 1.5 sheets wide, maximum. It's suitable for tiling with control joints in either direction, and you have to apply a liquid membrane. All right? And then they say, not suitable above a habitable room or living space. Right, so that's what I mean by you have to actually read all the words, not just look at the pictures. So this talking about pictures, eventually it'll come up. Basically, that's what the picture is in the manual. Sheet, primer, membrane, tile adhesive tiles. What it doesn't say on that picture is not suitable above a habitable room or living space. Waterproof with a mortar bed, staggered sheet layout like I told you before. That's suitable for large decks for this product. It's suitable for tiling, and it's the minimum requirement over a habitable room or living space for that particular product. And it's achieved via a liquid or sheet applied membrane. They call it a slipper sheet, but again, slip sheet above the membrane, reinforced mortar bed. And again, that's the picture, and what it doesn't say is minimum requirement over a habitable room or living space.